Hello and welcome to presentation 3 of 7 for Electrical Principles and Technologies. It's the Alberta Grade 9 curriculum. Electrochemical processes and applications. Electrochemistry. Alessandro Volta made the first practical battery around 1800 by piling zinc and copper plates on top of each other, separating them with an electrolyte-soaked paper disc. Humphrey Davy filled an entire room with about 2,000 cells to make one massive battery. His work led to a whole new field of science called electrochemistry, the study of chemical reactions involving electricity. Electrolysis. Smaller batteries were used to split molecules into their elements, a process called electrolysis. Many industries used electrolysis to separate useful elements from solutions. Chlorine to make drinking water safe, fuel for space shuttles to get pure hydrogen and pure oxygen. Electroplating. Silver and gold plating can make jewelry and other attractive items look very expensive. A thin coating, which is usually stronger than the original element, is produced through a process called electroplating. This process is often used to protect the metal from corrosion. Electroplating is also used to help prevent rusting of metals exposed to the elements in the environment. Anodizing is a process that coats aluminum parts with a layer of aluminum oxide. It is much harder than aluminum. It is used in products such as screen doors, airplanes, car parts, kitchenware, and jewelry. Electrorefining is used to remove impurities from metal. Another process used by automobile companies bonds special paints onto car parts. The scientific definition of energy is the ability to do work. Energy is found in many forms. The four most common forms of energy are chemical, potential or stored energy in chemicals released when the chemicals react. Electrical, energy of charged particles transferred when they travel from place to place. Mechanical, energy possessed by an object because its motion or its potential to move. Thermal, kinetic energy of a substance relative to the heat energy of the particles. As energy can be converted from one form to another, measuring energy inputs and energy outputs allows you to calculate the efficiency of devices and systems. This will be dealt with in depth at a later time. Biological electricity. Certain animals, like the electric eel, can produce electric shock, which kill or stun prey. They have a special organ that contains specialized muscle cells called electroplaques. Each cell produces a small amount of electricity. When all the cells work together, a large amount of electricity is produced and used to help the eel survive. Heat to electricity. A thermocouple is a device that can convert thermal energy into electrical energy. It consists of two different metals, bimetal, joined together that conduct heat at slightly different rates. When heated, the difference in conduction results in electricity flowing from one metal to the other. The basic principle of the thermocouple was discovered by Thomas Johann Seebeck in 1821 and was named the Seebeck effect. Thermocouples are used for measuring temperatures in areas that are too difficult to access or too hot for a regular liquid-filled thermometer. Light to electricity. Solar panels containing photovoltaic cells can convert light into electrical energy. The photovoltaic or PV cells or solar cells are made up of semiconductor materials such as silicon. When light is present, the material breaking electrons loose, allowing them to flow freely and absorb some. This current is drawn off by metal contacts on the top and bottom of the cell and then used in devices such as calculators, heaters, or emergency telephones. Individual solar cells are combined in modules to form arrays to produce larger amounts of electric current. Motion to electricity. A barbecue spark lighter uses the Piezoelectric effect in reverse. When a crystal or Rochelle salt is compressed or pulled, a potential difference is built up on the opposite side of the crystal. Conductors then take this through a circuit to produce an electric spark or electrical energy. Electricity to heat. Ovens and heaters do the opposite. They convert electrical energy into thermal energy. A thermoelectric generator is a device based on a thermocouple that converts heat directly into electricity without moving parts. So here's an example of a thermocouple. You have metal 1, a junction, and metal 2, and a small voltage being produced. Several thermocouples connected in a series is called a thermopile. Thermopiles are extremely reliable, low-maintenance devices and are often used in remote locations for emergency power generation. So here you can see several thermocouples connected together. Electricity into light. An incandescent resistant filament or load glows white hot when electricity is passed through it. In fluorescent tubes, a gas glows brightly, and when the crystals are struck together, they can produce light. LEDs, or light-emitting diodes, are solid-state components that use a fraction of the power of either incandescents or fluorescent bulbs. Electricity to motion to electricity. The piezoelectric effect produces sound by converting electricity into motion or vibrations. When a piezoelectric crystal such as quartz or Rochelle salt is connected to a potential difference, the crystal expands or contracts slightly. Material touching the crystal experiences pressure, creating sound waves or vibrations. Motion to electricity. The opposite can work to generate electricity by applying mechanical pressure to a quartz crystal, which will vibrate and cause an electric discharge or a spark, which is how the barbecue lighter worked.